All right, we will go ahead and get kicked off here. Just want to start with a quick introduction. Moving my screens all around here. So, welcome. Thank you for joining us for the Sustaining Barley Webinar Series, where we strive to have a forum for conversation and sharing of really good ideas on how to advance sustainability in the malting barley industry. We hope you'll join us over the next few months as we bring forward innovative research and practices throughout the supply chain that's helping the malting, brewing, and distilling industries meet their sustainability goals. I want to thank my partners on this series. Gina's on the call now with the Brewing and Malting Barley Research Institute, along with the Canadian Malting Barley Technical Centre. I know we've got some folks on there from here as well. And then also a big thank you to all of our members at AMBA that help make the content possible. So I just wanted to do a quick sneak peek of next month's session. So if you have not gotten registered for that yet, I would encourage you to do so. And with that, I will go ahead. There's that QR code in the corner there if you want to take time to scan it quick. You can get registered for that. But I'm going to go ahead and stop my share. All right. And as I finish up introductions here, Dr. Lee, if you want to go ahead and get your presentation queued up, we'll do that. So for today, each of our presenters will speak for about 20 minutes, leaving 20 minutes at the end for Q&A. Feel free to drop any questions you have in the chat or come off mute at the end and join the conversation. Again, we really want to encourage discussion during this series. That's why we keep it in the open meeting format. But with that, I'm excited to introduce our first speaker, Dr. Yin Lee, Data Science and Innovation Director. And he leads research innovation and machine learning at Malteurop North America, located in Milwaukee, Wisconsin. He has a PhD in fermentation engineering and has dedicated over 10 years to Malteurop, assuming roles in quality, technical expertise, and research and development. His extensive contributions to the malting and brewing industry are reflected in the publication of more than 50 research papers in peer-reviewed international journals, alongside the authorship of a book on malting and 2 global patents in malting technology. He augmented his proficiency in AI by accomplishing 10 global certificates in data science and machine learning from Johns Hopkins University. So you can all see why we thought when we were going to do a webinar on AI in our industry, that of course, Dr. Lee would be a great one for that. So with that, I will turn it over to you.
Thank you, Ashley. Can everybody see my screen? Can everybody see my screen?
Yes, it's looking good.
Yes,
okay. Okay, great. Good afternoon, everyone. So today I will talk about how the cutting-edge artificial intelligence and the Industry 4.0 technology are reshaping the malting industry. As we know, the malting begins with barley, but its supply chain faces challenges like climate change, shifting consumer demands, and the need for greater efficiency and sustainability. This talk explores how AI tools and smart malthouse address those issues, showcasing the real-world applications. So we know the malting industry is standing on the brink of a new era. Integration of cutting-edge AI, big data, and deep learning technology. Those tools are not just to enhance our ability to process and analyze data. They are fundamentally redefine how we approach every step of the malting process. So the question is for our industry, what is the next industry revolution in malting? The malting industry has been significantly advanced over the past 150 years due to the implementation of scientific principles and introduction of mechanization. So during the Industry 1.0, mechanization powered by steam and water replaced the manpower. What happens in Industry 2.0? Our human beings introduce electricity and assembly lines, enabling large-scale production. What happens in Industry 3.0? We invented computers and automation. Today, we're in Industry 4.0, defined by AI, big data, and IoT, Internet of Things. One major trend in the future of malting industry is the increasing use of big data, artificial intelligence, and machine deep learning technology. This evolution showcases how the innovation drives our industry forward. So now the question is again, what is the next industry revolution in malting? So the malting and brewing industry has recently experienced a surge in adoption of AI. AI-driven systems have already started delivering tangible benefits such as reduced cost and enhanced process consistency. A particular exciting subset of AI machine learning and allows the system to automatically learn and improve from data without explicitly programming. This capability unlocks the new levels of innovation in malting by enabling smart decision-making at every stage of the process. The true transformative power of AI lies in its ability to enable genuine human-to-machine interaction and turning the traditional malt house into a smart malting factory. So I have talked a lot about AI, machine learning, and deep learning. So what is AI? Artificial intelligence is the concept of creating smart intelligence machine. What is the machine learning? Machine learning is a specialized subset of AI that allows the system to learn from data without being explicitly programmed. Finally, we have deep learning is a subset of machine learning that uses a vast amount of data and complex algorithms such as the neural network, artificial neural network, ANN, to train models. This enables breakthrough like real-time quality prediction and adaptive decision-making, turning traditional malt house into smart data-driven factories. So in the smart malting factory, as shown in the left side, in the future, we're going to have a smart barley procurement, smart logistics, smart malt products. We use big data, cloud computing, Internet of Things, sensor readings, system integration, and we create a human-to-machine interface HMI. So what are the features of smart malting factory? We have interoperability, which enables seamlessly communication between machines, sensors, equipment, and people. And we have information transparency, which creates a digital twin of the physical malting environment by contextualize the data collected from sensor. These features allows us to visualize and predict outcome in real time. Finally, technical assistance takes center stage. AI supports monsters by providing the data-driven insights for decision-making and problem-solving. This is especially valuable in optimizing operation and developing tailored solutions for customers. So we believe the transition from Industry 3.0 to Industry 4.0 is not just a technical upgrade. It is a strategic necessity for the future of malting operation and business. While the Industry 3.0 brought us automation and computerization, Industry 4.0 takes this a step further by integrating advanced technologies like AI, machine learning, and Internet of Things, IoT, into the very fabric of the manufacturing process. So in terms of AI roles in the malting operation, let me break down of the key areas where the AI make a significant impact. Barley procurement assistance. AI predicts barley quality during the growth, enabling the better supplier scoring and ensuring that only the best raw material into the malting process. Process optimization. AI enhances steeping, germination, and kilning by continuously analyze the data to optimize time, temperature, and moisture condition for maximum efficiency, QA and QC. AI use predictive model to ensure that final malt meets quality standards by analyzing data from raw material. New malt product development. AI evaluates the market trends and the consumer preference, helping us develop innovative malt products tailored to the specific brewing and distilling needs. Predictive maintenance. AI prevents equipment failure by identifying potential issues before they occur. Customer experience. The AI can assist the brewer by recommending the best malt options and creating the customer recipe, enhancing satisfaction and product differentiation. So from the barley procurement assistance perspective, AI can predict barley quality by analyzing factors such as growth conditions, weather patterns, and supplier performance. This helps us make better decisions and reduce logistics costs by sourcing from the most reliable suppliers. So precising barley variety identification by leveraging AI-powered image recognition, even with the smartphone image, we can precisely identify barley varieties. Barley, new barley variety development. AI is in breeding barley variety tailored to brewers' specific needs by analyzing the customer preference, brewing performance, and environmental data. We can develop the new barley varieties that tailor both high yield and excellent malting characteristics. So machine learning is transforming the barley breeding by uncovering the actionable insights from the big data. The first is predictive breeding with machine learning, and the second is for the effective breeding application. And you can see this is the article published in the Plant Science, Trend in the Plant Science, just published. And this approach integrates genomic phenotype and environmental data from the molecular markers to drum, image, and climate matrix, creating a data-driven system that accelerates the breeding cycle and improve outcomes. AI for process optimization. In the steeping, AI can enhance the recipe selection and moisture absorption, germination, and curing. AI can predict malt modification during the germination and ensure the precise color and flavor development during the curing, as shown in the left side of the graph. For the sensor data analysis as shown in the left side of the graph, you can see the AI-driven insights from the sensor data redefine the process optimization, ensure the operational improvements and the consistent quality. These innovations are streaming production while meeting the growing demand for quality and sustainability in malting. AI for QA and QC. Predictive of quality analysis. AI can predict the final malt quality based on the raw grain and process conditions, improving the efficiency and reducing the variability. Real-time adjustment. AI replaced the manual inspection by adjusting process in time to meet precise specifications. Optimize the schedule. By optimizing the malting schedule, AI minimize the downtime and increase the throughput, enhance operational efficiency. AI can drive the process, improve the malt quality, boost the brewing performance, and reduce the waste, create the values across the supply chain. So how the AI for the new malt product development? AI can identify opportunity by analyzing the customer demands and brewing trends, ensuring that we meet evolving expectations. With big data, AI develops recipes customized to individual customer needs, enhancing both efficiency, and creativity, particularly values in the craft brewing sector. And AI supports the creation of unique, specialty malt products, helping the brewers innovate and differentiate their offering. So how the AI for predictive maintenance in malting. By analyzing the sensor data, AI predicts and prevents equipment failure, enhancing operational efficiency. While with the predictive scheduling, the repair are conducted before the failure occurs, ensure that seamlessly production and reducing the cost for the business and operation perspective. AI for customer experience and engagement. AI helps the brewer select the perfect malt products and generate customized recipe, meeting unique brewing requirements. By analyzing data from diverse sources, AI deliver actionable insights for better decision making and a deeper customer engagement. AI and machine learning aim to provide full managed service, streaming the brewing process for the greater efficiency. This approach significantly improve efficiency and give customer a better experience across the brewing industry. So now let me share with you an exciting case study from Malteurop, our malt extract prediction by AI project. This initiative highlights how to leverage advanced AI technology can optimize one of the most critical quality parameters in malt extract levels. As we know, the malt extract levels determines the beer production efficiency and is a key quality parameters for masters and brewers. However, predicting extract level isn't straightforward. It depends on multiple factors like barley starch content, kernel characteristics such as the whole thickness and process variables like enzyme activity during the malting process. So understanding the challenge, we started using AI and data science to better predict and improve extract levels, ensuring both quality and efficiency in our operations. We analyzed the 10 years of historical production data from a single plant. By training the machine learning algorithms on this data, we developed predictive models that provide insight into the barley supply chain, malting operation, and product quality. Our goal was clear: to enhance the procurement predictability, optimize the barley cleaning process, improve malt quality, and increase our inventory reliability. So this diagram illustrates the deep learning artificial neural network ANN architecture developed for our malt extract prediction project. On the left, you can see that the input features, those are the black dots. We can see the input features, including barley variety, barley quality parameters. These inputs feed into a multi-layer neural network represented by the interconnected nodes. The network processes this data layer by layer, identifying the patterns and relationship that are not immediately apparent. Finally, on the right, we have the predicted outcome, FGDB, which is a critical parameters for evaluating the malt quality for this project. So moving on to the results, this graph demonstrated that effectiveness of our AI model is predicting the malt extract compared to actual data, lab data measurements. The AI model was trained on a data from 1,500 production batch and validated on 150 real plant scale production batches. On the graph, you can see each dot represent a batch real extract value versus the AI predicted value. The strong alignment along the diagonal line highlights the model's accuracy. With the average precise prediction difference of only a 0.57 extract unit, almost within the one standard deviation of lab analytical precision. So these results showcase the robust of our AI system in the real-world condition, providing consistent and reliable extract prediction that support decision-making in malting operations. So I like to mention that the content of today's presentation has been published in the Master Brewer Association of the American MBAA TQ. And this article titled Exploring the Use of AI and Industry 4.0 in Malting, a case study of an extract AI prediction project, provide a deep exploring of the topic we just discussed. So that's all about my presentation. Thanks everyone for attending the webinar.
Excellent. Thank you very much. And we will hold off on questions just so that we can get both presentations in first. But please, if you have any, either hold on to them or drop them in the chat and we'll make sure we get them asked after our second presentation. So I'm going to go ahead and let's see here. Are you able to stop that share? If not, Federico, if you want to go ahead and just start your share, I think that'll cancel out Dr. Lee's.
Yeah, try to
There we
see how.
go. Let's see here. 1 second as we work through this. All right, hopefully we've got the right one up. Yep, I see that. Hopefully everyone else is. Excellent. So I will go ahead and do just a brief introduction before we get started here. So I want to thank Federico Casale for joining us today. He's a data scientist with extensive experience in barley genetics, so an excellent combination for this audience. He holds a BS in agronomy from the University of Buenos Aires in Argentina and an MS from the University of Illinois in the US. He also has a PhD in quantitative genetics from the University of Dusseldorf in Germany. And during his doctoral studies, Federico focused on innovative methods to manipulate recombinant rates in barley breeding programs. He's now at Computomics, where he leverages his machine learning to help plant breeding companies achieve their goals through the advanced xSeedScore platform. And I just have to say that I actually saw a presentation on this platform over a year ago now and was just really blown away about just the opportunities that it presented. So I'm really glad that we've got Federico here today to help share this work. So with that, I'll turn it over to you.
All right. Can you listen to me well?
Yes, coming through good.
Perfect. So thank you so much for the very nice presentation, Ashley. So I'm Federico Casale. I'm data scientist at Computomics. So today I will introduce yourself to the technologies we have available for plant breeding and specifically for malting barley breeding. So, are you listening to me?
Yes, you're coming through good.
Okay, perfect. So, we have a different set of technologies. Typically, we got data from customers, typically genotypic data, phenotypic and environmental data. And our technologies are capable to process this data to generate different kinds of outputs. The outputs can support plant breeding programs at different levels, from increasing the efficiency of in plant breeding programs, like improving the selection process or the allocation of resources, to more important decisions, like transforming the plant breeding scheme or selecting the most important material to start a recurrent selection program. Also, we have technologies to identify more genomic oriented, like to identify the most important parts in genomes to proceed for plant transformation or gene editing as well. So I will base this presentation in our core technology, which is the xSeedScore, that is machine learning-based predictions. The essential of the xSeedScore is that machine learning models are trained with data like phenotypics, typically phenotypic and genotypic data. And once these models are trained, these models are able to predict the performance of genotypes at different levels. And these predictions and are then delivered to our customers, which are typically breeders, and they use this information to improve their selection process. We use machine learning for predictions because machine learning models are very efficient to calculate complex interaction between predictor variables, for example, nonlinear associations among traits and markers, and environmental factors as well. Also are very good to easily calculate non-additive genetic effects in the genetic architecture of traits, and also are able to process very efficiently large amounts of data. Our platform can process any kind of data, but the basics is phenotypic and genotypic data, and also basic environmental data like location and year. However, the platform can also process environmental and soil information, as well as field management data. So I will jump into a more specific use of xSeedScore for malting barley breeding. So this is a standard breeding cycle for malting barley. It starts with crossings to generate families. Within the families, the material is self and selective through a phase that we call the variety formation period. And then during this phase, at the end of this phase, the varieties are selected and advanced to yield trials. In the yield trials, the selected varieties are tested across several locations, across several years, and then the very top ones are advanced to pre-commercial trials, during which the selected varieties are tested in multi-locations before the final commercial launch. Within this process, the xSeedScore can support different phases. We have a long experience with predicting the performance of varieties that are finishing the variety formation phase, and we are able to predict their performance in the more advanced yield trials. This is done by training the models with genotypic, phenotypic, and environmental data from the most advanced phases. And once the models are trained, we obtain genotypic data from the varieties that are finishing the variety formation phase. And with these genotypes, we are able to predict their performance in the more advanced trials. And so with this information, the breeders can select better what material to advance. This trained models are also useful to predict for the performance of material that is still already present in the breeding program. So to predict their performance in potential commercial regions for the material that is already available in the program. To go more into the details, the main advantage of the platform is that it finds the best predicted model for each trait. And when it comes to barley breeding, this is very important because in malting barley, not only the agronomic or the yield-related traits are important, but also the grain and the malting quality traits are crucial in the breeding process. Sorry? Okay,
I
I
think
will
we're
go
just getting
ahead.
some feedback, so I'll figure out and get them muted, okay?
Okay. Um, so, um, our platform is very flexible for different types of traits, and one of the main factors behind this is that um, it can address different trait genetic architectures. So it's very well to predict for yield for traits like yield that are very quantitative, so explained by many loci in the genome with a small effect. But also it's very good to predict for traits like malting quality traits uh, that most are explained by a few loci with large effects, plus other loci, many loci with small effects. So our platform can define automatically which is the best model or ensemble of models to predict for these different kind of genetic architectures. Also, machine learning is very well to calculate G by E, so genotype by environment interactions. And this is very important in barley because, again, there are many traits and there are usually several target locations or regions for the breeding program. So with different commercial partners, we have predicted for different regions within the US and also in different countries in the world. One important aspect here is that our platform is capable to process also weather, soil, and field management data. And with this, we can predict for future conditions, extreme weather events, and also for unseen environments. And this is very important for breeders when taking decisions in the long term. I cannot provide you real data from commercial projects because of confidential reasons, but I go over briefly through a project we have done with the University of Halle in Germany, in which we have used machine learning to identify the most important markers to predict flowering time, score as days to heading in different countries of the world, and also to predict for flowering time in environments that have not been seen during the investigation. So the material that has been used during this project was the HEP25 barley NAM population, which involves 25 barley families with in total over 1,000 lines. This has been genotyped with with many markers, but we have used almost 200,000 markers. And these lines have been phenotyped in 7 countries at 2 years. Yeah, so briefly, our models, sorry, our models have been trained with 45 environmental variables and with an incremental number of markers. And in this way, we selected the best subset that explain flowering time to predict flowering time in barley. With this selection of markers, then we predict for unseen environments. And you can see here that for different unseen environments, we obtain prediction accuracies that range from 0.56 to 0.63, depending on whether we used environmental data or not. So this is a small example of what we can do with xSeedScore. Another Another application of the xSeedScore is the simulation of authoring in breeding programs. This is to select the most promising parents to restart recurrent selection cycle. So basically, we use the genotypes of potential parents to simulate the recombination among them and simulate the offspring that the cross can generate. With these simulated genotypes, we can predict then, using the xSeedScore, we can predict their performance in the field. The pipeline that we have in-house can be customized to meet any breeding scheme. It uses a machine learning-based recombination simulation that is unique in the market, and it's always validated on real data. These simulated genotypes then, as I said, can be used to simulate the phenotypes and so the performance of the offspring at different stages in the breeding cycle using the xSeedScore. So this was a summary of the xSeedScore capabilities for barley breeding. To wrap up, we have a set of technologies that can be used at different levels in breeding programs. It can be used from increasing the efficiency of the use of resources in breeding programs and in the selection decisions to more important decisions like transforming the breeding scheme or selecting the best parents to restart the cycles again. And also we provide services that can be used to identify the most important regions or loci in the genome for gene transformation or any other plant transformation, or also to investigate any trait in detail. Also, our technologies are very flexible and can be customized to meet any needs of any customer. In the particular case of the xSeedScore, the basic data needed to start using it as phenotypic and genotypic data of genetic material that has been scored in several locations at least 2 years. We always provide support on how to genotype and how to phenotype properly a breeding program. To provide I wanted at the end to provide a brief summary of the company. Computomics was founded in 2012 by worldwide recognized scientists. Now we are almost 30 people from different regions of the world, most with very strong scientific background. We have a long experience working with plant breeding companies in the Malting Barley breeding industry. Our main partner is AB InBev. In addition to the xSeedScore, we provide other services as BreedScope, that is the assessment of the plant breeding program, and that includes some recommendations, metagenomics analysis, and very important, the Malteurop, which is a tool for the visualization of plant genomes, so to analyze genomes, whole genome sequences at the nucleotide level to take decisions for different plant transformations or analyzing any trait. We also provide different services, bioinformatics services, so don't hesitate to reach out to us in case you have any question. These are our contact details, and I'm happy to answer any questions you may have.
Excellent. Thank you very much for that, Federico. If you want to go ahead and stop your share, perfect. Thank you. And folks can go ahead and come off mute and feel free to turn your camera on as well. And I think I'll just kick us off with one question, and this is for both speakers. This is the Sustaining Barley Webinar Series. So a lot of the work that we're doing is really trying to help bolster sustainability within the industry. And so it might be really obvious with both of the presentations today how this could do that, but maybe specifically address how you see AI or machine learning being able to address issues around sustainability in barley production.
So I can speak first. Yeah, actually. So probably from from my perspective, AI, yes, can help with the sustainability and the environmental impact. For example, like water and energy uh, conservation and green process optimization, which is used AI can simulate the different process in the malting configuration to find the most water and energy efficient approach and ways and the equipment or the configurations, and also can help. This is the same practice for the brewers. They can do the same practice. And another way is for the CO2 recapture. So AI can model and optimize the carbon CO2 capture system in the fermentation, help the brewers reduce the emission and potentially, um, uh, reutilize the CO2 in the packaging of the process. So another way is local, from my perspective, is ingredient substitution for the lower carbon footprint. Everybody right now is doing it, wanting to lower of their carbon footprint. So local resourcing is one of the suggestions. So by factoring of the transportation of distance, availability, and quality, so AI can propose the ingredient substitution to reduce the carbon footprint or support of local of agriculture without of compromise of your beer quality, flavor, all those kind of things. And another way is probably is alternative grains and some of the novel adjunct. And use the AI model can, because it's based on the big data, and use the AI, especially like a generative AI, and can consider of the new grains or non-traditional adjuncts that might provide unique flavors that require fewer resources to cultivate. In that way, we can work as teams to achieve the overall sustainability of goal. That's just my 2 cents.
Uh, yeah, to me, there are 3 important points. The first one is the machine learning or AI can decrease the impact on the environment of both agriculture and industry. I think Jean Lee talked a lot about that, but also particularly in plant breeding can um, make the plant breedings make the plant breeding programs shorter to have a more plastic response of the plant breeding sector to the environmental demands and the market demands. That's one point. And the other important point is that machine learning predictions can better predict the future of different environmental conditions, and that may help breeders to take decisions on the long term to cope with the changing environmental situations. So these 2 things are, in addition to what Jean Lee told, are to us at least very, very remarkable during our customer relationships.
Great, thank you. What other questions are out there?
Actually, I have a quick one here.
Yeah.
Yeah, this is more for Dr. Lee on the AI applications, maybe more focusing on the process improvement. I'm wondering in the industry, Dr. do you see a big CapEx expenditure we will need to have to fill in the gap, because just the technology itself may not easily applicable. Things like sensors or inline measurements, etc. So could you comment on that, please?
So, Dr. Shang's question probably is think about you are asking if they need a huge amount of capex investment on the AI side to doing some projects for each company. Is that your question?
Yes, that's right. Yeah.
So Initially, I started doing the AI project probably 6 years ago, and I do see some of the companies starting with very big of the capex at the beginning. They invest millions of dollars. Once you invest a lots of monies, and then your your finance will judge you ROI and will judge you investment return. Those kind of question. But with the AI technology, no longer is 6 years ago. And with the advance of especially cloud computing and Internet of Things connection and generative AI technology. So right now, I do not see much of the investment of for doing AI projects for the investment in terms of capex, because we do not need to buy a lot of GPU. We can buy through the API to build those kind of AI applications and build AI agents for each of your business needs. But when each of the companies started with AI project, I think one of the most important things is the quality of the data, because you have to validate, as human beings, we have to validate the data is reliable and accurate. Otherwise, you just garbage in, garbage out. Those are the things, I think, when we wanted to start AI projects.
Thank you. And then technology-wise, do you see this, you know the industry very well, do you see this will come into the industry in a year or two, or 10 years or 20 years? How quickly this might be coming to the industry?
This should be within the 3 to 5 years. The moving of technology always faster than we think. Yeah.
Good. Very exciting. Thank you.
Thanks, Dr. Sheng.
Juan.
Yes, Ashley, thank you. I have, well, my name is Juan Montes. I'm a Chief Commercial Officer from Computomics. And I have a question for Dr. Lee. Really very interesting presentation. And I wanted to ask a little bit more about the challenge that you might have encountered with regards to the data for the project that you have done, because I can imagine it's not easy to get all the data from a malting process. I think you mentioned historical 10 years of data, right, for your project. So I'm curious about, how were the challenges with regards to the data for such a project, and if you could recommend, some or provide some advice for other companies that want to do the same.
Yes, yeah, thank you. That is a very good question. So there were old saying is in the future, data is the new oil or the fuel for the in the AI age. Yes, you do need a huge amount of the data. However, you wanted to those data collected structurally for each of the batch or each of the loads or those things. So luckily, we have been collect those data very well. Storage in the ERP, those SAP system from the barley quality process information and sensor readings, including the malt quality data. That's good. However, I do think some of the projects, if we extend for the barley supplier side, especially for agriculture practice or the weather information, those are the things or fertilizer use. I do talk to farmers, and those data is very difficult to. Some of the farmer may be good at to collect the data. Some of the farmers are not that. Yes, that's a good point. Because if the missing data, we can miss some of the data to build a small model. But you do not want it to miss a huge amount of data. In that way, you're going to lose your extraction of the key features of your project or the model.
Thank you.
So another suggestion is starting today, collect all of your reliable data. Talk to all your colleagues who could collect the data to let them to understand the importance of those data.
Great discussion so far. What other questions are out there? Maybe everybody else's head is swimming like mine because this stuff is all pretty new to me, but it's very interesting to hear about. Right, well, I'll leave it open for just a little bit longer. If anyone has any lingering questions, I'll just put up one more slide here just for, let's see here. Maybe that did not share. Start that again. Just wanted to just put up the slide for next month's webinar, where we'll actually be discussing winter cereal potential and its opportunities to bolster sustainability within barley production. We've got speaker from US and Canada joining us talking about their winter barley programs. So let's see if I can get that share to work this time. Is that showing up now or no? Yeah, maybe? Awesome, good. All right, well, just open it up one more time for any more questions. All right. Well, I just want to thank both of our speakers today for your time and your content. And as always, we'll get this recorded and posted online and shared out to everyone. And with that, I will say goodbye. So thank you.
Thank
Thank
you.
you, Ashley, also. Bye.